Okay, thank you very much, members. We are going to start from where we stopped last time. And we were handling transport in plants. And we had now remained with the few things to finish. One of them was measuring the rate of transpiration. Remember, we had talked about the diagram of an open stomata. We talked about factors that affect the rate of transpiration, which also we had some discussion on when we were. Members, I think let's minimize the noise so that we are able to concentrate here. So we had talked about those factors. There are factors which are environmental, others are physiological or structural. So the environmental factors are those factors of the environment that influences. Hey, Sandra, can you mute? Sandra, mute and listen. Okay, that's. So factors are those factors of the environment that influences, in this case, the rate of transpiration. Rate of transpiration means the speed at which transpiration occurs. Now, one of them is the temperature. I have told you that temperature has a tendency of generally increasing the kinetic energy. Mr. Wadmon should have told you about kinetic energy, the energy of moving objects. Now that means once the speed of movement of molecules like water increases because of increase in temperature, even the speed at which it escapes from the leaf surface also increases. So we are saying that temperature also heat. This heat produced increases the latent heat evaporation. That evaporates. All of you are aware when you are trying to boil your water, as the temperature of the water increases, you see more vapor escaping. That's exactly what happens on the leaf surface. As the temperature increases, the evaporation of water increases. And that evaporation results into increased tendency of water. So mainly two aspects to explain this. One is that increase in temperature increases the latent heat of vaporization, which increases the tendency of water escaping into the atmosphere. Secondly, that same temperature increases the kinetic energy, and kinetic energy increases the speed of movement of molecules from the leaf surface, and therefore is an increased rate of diffusion, which is a very important aspect as we explained this. Increasing the rate of diffusion from the leaf, and then the kinetic energy is increasing, and then increase in the latent heat of vaporization. That means that more water molecules evaporate. Now, the second factor is what we are calling relative humidity. You know, when we talk about relative humidity, we don't mean humidity. The atmosphere is always humid. As humidity increases, the rate is high because the environment becomes saturated with water vapor. And once the environment is saturated with water vapor, it means that it means that the water absorbed from the plant will increase and therefore reduces the rate of transpiration. You know, once it is remember, water moves to the zone of low concentration. Another one, we are talking about wind speed. Of course, if the speed of wind is higher, it will blow off moisture as fast as possible. Now, that blowing of moisture will then result to more vapor being removed around the surface of the leaf. If the speed is too high, then there is what we call a mechanical closure. It results into closure of the stomata. So the wind must be moderate, not too high, not too slow, but it should be high enough to blow off any vapor that is produced. Once it is swept from the leaf surface, then more water will be able to escape. Another environmental factor is light intensity. Of course, like I've told you, light increases the rate of photosynthesis in the leaf. When the intensity increases, then you have higher rate of photosynthesis. Now, the higher rate of photosynthesis means that much sugar is absorbed or synthesized in the leaf. Once sugars are synthesized, like in the stomata of those leaves that have chlorophyll, what will happen is that that sugar concentration will allow absorption of a lot of water. And of course, that absorption of water then results into wider opening of the stomach. Because the cells become turgid, just like I was trying to explain to you. Now, once you have those guard cells, of course, you have that, and then there is a guard cell there. Of course, there are tissues, there are other cells, epithelial cells that surrounds them. I'm not interested. But now this guard cell here has chlorophyll. Once they become concentrated with sugar as a result of increased photosynthesis, then you will find that more water enters inside. Once the water enters, then these cells stretches. But because inside is flexible and outside is rigid because it has a cell wall, then you will find that the inside will pull out. And then the inside will also pull out, resulting into widening of the stomata. So the stomata opens up. And because of an open stomata, then you'll find that we are going to have an increased rate of transpiration. It is very important for us to take note of that the intensity of light does not directly influence the rate of transpiration, but for it, the rate of photosynthesis increases. So it increases the sugar concentration in the guard cells, which leads to the widening of the stomata. So light will provide the opening of stomata or the escape of water from the stomach. That's another environmental factor. Another environmental factor is availability of water. Once there is more water, there is an increased turgidity of the stomatal cells. And of course, it results in more loss of water. Another environmental factor is the atmosphere. Once you have a leaf surface to draw it, you have okay. This one has if the environmental factor is too it tends to escape that is being pressed, meaning that as the environmental pressure increases, it's a tendency of suppressing water so that water cannot evaporate from the leaf surface, especially if the environmental atmospheric pressure is higher than the pressure being generated in transpiration pool. Then definitely we will have the escapability of water decreased. Therefore, in atmospheric pressure decreases rate of transpiration in atmosphere results into an increase because the water molecules, the water vapor escapes more rapidly. Then there are other non-environmental factors which also we have to take into consideration. One is the distribution of the stomata. Of course, once the stomata is distributed in a direction closer to the light, that is on the upper face. Okay, so members, I have decided that you can record if you want. And I have given you today an option of recording so that you can view them later if you need, or you can review the lesson. But of course, don't spend a lot of time once you've started recording. Leave it and concentrate more. So we have that atmospheric pressure. We look at non-environmental factors. One is distribution of the stomata, where I have told you that when they are on the upper surface where there is direct sunlight and then there is more heat, then definitely the rate of transpiration is important. By the way, these factors are very important when you are determining how plants have adapted to high light intensity. One of them is that they have most of their stomata on the lower surface, such that less water escapes. Number 8, which is a non-environmental factor. Remember, it's not a factor of an environment, is the number of the stomata. Of course, the number of the stomata also greatly affects. When they are higher, when there are many stomata, that means that there are many avenues through which water can escape. And based on that, we see that the higher the number of stomata, the greater the rate of respiration. There are many avenues through which water can escape. The surface area is the total area available for contact between solid and liquid. So when the leaf is very wide, definitely an increased surface area to absorb sunlight, to absorb heat, then to accommodate water, and therefore it will allow the water to escape. Another one is the thickness of the cuticle of a plant. Of course, most of our leaves have cuticle. Remember, once it is thick, then it reduces the tendency of water to escape. And therefore, the thicker the cuticle, the slower the rate of transpiration. These are non-environmental factors. Remember, environmental factors, number of area for thickness, this to itself. Nothing to do with the non-plant. Then we are going to look at how does the process, how does the stomata opens and how does it close. And that is what we are calling the mechanism for stomatal opening and closure. But you must be aware that most plants have their stomata open during the day and they close at night. But you've been wondering, why is it so? Why does the stomata close at night? And then why does it open during the day? It is a very critical issue that we all need to understand. Now, members, there is an analogy that I would want you to get to know. There are some plants whose stomata closes during the day.
Teacher.
Yes?
I can't see the side of your work.
Because I'm explaining. I have first removed that work because I am explaining. Is it okay?
Yes.
Sometimes you keep on reading instead of listening to me. That's why at times I remove it so that you can concentrate and listen to my explanation. Sometimes the explanation are more better than because those notes of them. That's why sometimes you see me bringing when I'm demonstrating something. Now, you've been wondering why people say during the day the stomata opens and at night it closes. Now, the theory that has been designed, which we call the starch sugar interconversion theory. Now, this theory has been designed to So I was trying to explain this.